Guys, Mr. Gerald here. That's probably. I think there's three that we're going to go through. Paul, working. Yes, it is. All right. How many do we have? One. Okay, we got. All right. Let's get right. The first one, authors of the article, accommodating persons with acceptance rejection in rental situations, stated that even though landlords participating in a telephone survey indicated that they would generally be willing to rent to persons with AIDS, they wondered whether this was true in actual practice. To investigate, the researchers independently selected. Oh, right. Yeah. They independently selected random samples of 80 advertisements rooms for rent from the newspaper advertisements in 3 large cities. An adult male caller responded to ad in the first sample of 80 and inquired about the availability of a room and was told that the room was available in 61 of these calls. All right, so I have one sample proportion of 61 over 80. The same caller also responded to the ad in the second. In these calls, the caller indicated that he was receiving some treatment for AIDS and was about to be released from the hospital and would require a place to live. The caller was told a room was available in 32 of the calls, so I have 32 out of 80 in the other. Based on this information, the authors conclude that reference to AIDS substantially decreased the likelihood of a room being described as available. The data support this. Let's carry a hypothesis test with significance level of 0.01. Okay, so let's find population proportion. Well, some versus a proportion t-test for difference in proportion. Pardon any like pen device that I'm using. If it's annoying, I find it annoying. Well, our null is going to be either p1 minus p2 is equal to 0, or p1 is equal to p2. Now, before I have my alternative hypothesis, let's define our proportion. So, let's say what I have in here. Yeah. Okay. Let's say if since I'm want to see if mentioning AIDS decrease the likelihood. Let's say it's proportion of callers granted a room when AIDS is mentioned. Not someone with AIDS, just someone saying that they do. The fact. And 2 equal to proportion callers granted a room no mention. So if that's the case, in this case, our alternative will be either that P1 is less than P2. Oh, sorry, I have this in the wrong order. Or P1 minus P2 is less. Okay, that gets us started. Let's before we check our conditions, let's write down some of the values that we have. So when I have P hat 1 is equal to 61 over 80, that's what we found. Oh, no, it's not, sorry. For the AIDS one, it's 32 over 80. That means Q hat 1 is equal to the complement, which is the other 8 out of 80. Have P hat 2 being 61 over 80. The portion of those who were given a room when no mention of AIDS. That means Q hat 2 is the other 90. Conditions. Delay thoroughly irksome. Okay, we're given independent random sample. Good. Um, 10% condition. We know N1 and N2 are both equal to 80. In this case, they just happen to be that way. Must be less than 10% of all, well, what's the sample of all responders to these housing ads, callers from housing. Okay. Last is last thing we need to do is check, see if we can use that bell curve. So what I need to do, N1 times P hat 1. Well, that's let's put my N1 here, my sample size of 8. Same with my N2. 80 times 32 over 80, which gets 32. That's greater than or equal to 10. N1 Q hat 1 equals 80. Whoa, what happened? What's going on? Okay, there's a delay which is bothering me. I have N2 times P hat. Oh, yeah, N2 times P hat 2. That's 80 times this 61 over 80. 61. All right, now have to do the same thing with our Qs. I have to do N1 times hat 1 and 2 times hat. Well, my N, both of these are 80. Oh my goodness. For our N1s, hat 1 is 38 over 80. You had 2, 19 over 8. Our answers here are just numerators. We get 48. 19. Both of these are greater than. Oh my god. 9. Dealing with some, but here, we're gonna do our test statistic 2 different ways. So one way I need Why is that over there? I need my combined p hat. So look at okay, this is much better. We're gonna need our combined p hat, sum of numerator. In this case, we have our sample sizes of 80. The numerators that we use, the, the numerator for the p hat 1, 32, and numerator for the hat 30. Okay, so that gets where we get 90. My hat, my combined p hat, means my q hat, hat 67. Okay. We have the alpha level of 0.01. The test statistic is formula is this. So let's plug some things in. This guy here is going to be 0. This is the null proportion. We got to have our difference of proportions, sample proportions here. So this will be our p hat 1 is that's the AIDS proportion, 32 over 80, minus the p hat 2, 61 over 80. Well, I'm going to miss 0 because that's what this difference is. And then we have to do our first square root has this combined p hat and this combined q hat. So 93 over 160 times 67 over 160. That's all in this square root house. And that's times 1 over n1, which is 80, plus 1 over n2. Well, n2 is also. If you do that math, the z-score that you get is negative 4.646. With that z-score, well, if the z-score is like at negative 4 and then we're doing a left-tailed test, I want this area over here. You can do a normal CDF if you want, or you can go right to the calculator. The p-value is equal to point, and there are 5 zeros and 168. That's definitely less than the alpha point. Let's run through how to do that in the calculator real quick. Put that over to test. We're going to proportions test. Then we just put in our proportions and our the type of the test direction. Then I have 32 over 80 there, and I have 61 over 80 for the other proportion, and we are doing a less than test. I calculate that. That's the t-score that we have. This is that p-value. There's times 10 to the negative 6, and we have the combined p hat if we need it. So that's another way to get them. With this, let's right. What did I say? Since p-val less than alpha, projecting all. What is this? So let's talk about what the problem is saying. Doesn't mean we have strong evidence that when AIDS is mentioned, that if AIDS is mentioned, the proportion of callers that are granted a room is much less than when AIDS is not mentioned. We have evidence, means we have convincing evidence that the proportion of callers who are granted a room much lower when, or say, if or when AIDS is mentioned than when it is not. There we go. It also has us to a 98% confidence interval. 98% confidence interval. Well, the conditions are already met. If you want to do that with the formula is this. Feel free to plug that in, but if you just say to proportion the interval, you can go right to the calculator. That Let's find it. Make sure it's not two samples the interval. We're doing two proportion, and it looks like it already knew uh, the parameters that we had just by doing that test. We just got to change this to 98. All right, so there's the confidence interval. Let's interpret these values. Okay, negative 0.1, negative 0.197. Okay, so wouldn't I say if AIDS is mentioned, the proportion of callers granted a room is lower than when it isn't mentioned by between 19 and 53%. That proportion is lower by that much, by between those two values. Or I mean, have to say that with confidence, right? So let me type that again. When I say I am 98% confident that the proportion of callers rent a room, AIDS mentioned lower than when it isn't by between 19.7% and 50. We know proportion is lower by between those two values. Okay, let's next. Let me erase that. Next one, let me conducted a medical study to investigate whether taking low dose of aspirin reduces the chance of developing colon cancer. As a result, a thousand adult volunteers were randomly assigned one of two groups. Half of them were assigned to the experimental group, a low dose of aspirin every day. The other half were assigned to a control group that took a placebo. At the end of 6 years, 15 of the people who took the aspirin had colon cancer, and 26 took the placebo. We want to see if there's a significant difference of these proportions. Okay. This again is a two proportion z-test. Let's define our parameter. One is equal to the proportion of, let's just say, since we have adult volunteers, we're going to say portion of similar adult developing, I'm just going to say colon cancer within 6 years. Yeah. Within 6 years after taking aspirin. And P2, I'm just going to say similar portion. I'm going to define it in a similar way, but by saying without taking aspirin. You're going to make sure you do that very clearly. Okay, so we're trying to see if this reduces uh, that that chance. I'm going to say this null is going to be that these proportions are the same. The alternative is that going to be that this rate is lower than that rate. Let's put down some values. Then we have p hat 1. Oh, my sample sizes are 500, right? Because they put these people in half. We have 15 over 500. Whoops. So then I can put my q hat 1 equal to 455. My n1 is 500. My p hat 2, I think it's 26. 6 over 500. That means if my q hat 2, those in the placebo group who did not get aspirin, that's going to be 474. Right, over 500. This also has a sample size. Okay, and we're testing this at the alpha level of 0.05. Okay, our conditions. While we don't have independent random samples, this random assignment is okay. That's a key thing to remember. Random assignment of both groups, or like of each treatment. Okay. Our sample sizes, um, are both 500. It's definitely less than 10% of similar adult. May or may not take aspirin every day. Okay. Third one, that's where we're doing our checking for normal. Wouldn't I do N1 N1 times at 1, that is equal to 500 times 15 over 500. Well, that's 15 greater than or equal to 10. N1 times 2 at 1 equals to 500 times 485 500, which is 485, much bigger than 10. Same thing if I'm doing N at 2, that's 500 times 26, 500, greater than, sorry, that's 26. And Q hat 2, 500 times 476 for 500, 476, that's all greater than. Okay. With that being said, we're good to go. We're good to make our test. With that in mind, Um, okay, our test system is going to need our combined cat if we're doing this by hand, which is going to equal the numerators over the denominators, the sum of them. So then we had 15 plus 26 over 500 plus 500. That gets us 41,000. So that means Q hat 2 is the other 959. Um, our test statistic is going to be, again, I got the formula here. All right, we got to start with our difference of proportions. So that's 15 over 500 minus 600. Keep that one and that 2. This guy here is 0. And what I'm dividing is 40 square root of 41 over 1,000 times 959 over 1,000 times 1 over n1 is 500, 1 over n2, that's also. Write it out there, that's fine. I forget what I got when I did this. Let's go right to the calculator. Just that over to tests. We're doing a two proportion Z test. Don't we have, my first proportion is 15 over 500. The other one is 26 500. Okay, let's test. All right, so I get a Z-score of negative 1.754. We would have got that if we did this math. Then the p-value is 0.03, 0.040. Okay, and we are told to use the alpha level of 0.05. So that means p-value less than the alpha. Yeah. So let's interpret that. Wouldn't I say this means we have convincing evidence that the proportion of, in this case, let's say similar adults who develop colon cancer within 6 years of taking an aspirin every day. That's our thing. That proportion is lower than the proportion of similar adults. Similar adults developing colon cancer without. All right, 2 down, 1 to go. Let's. Okay. Oh. Um, a test here. We're doing a confidence interval. Large company has 2 shifts, day shift and night shift. Parts produced by 2 shifts must meet the same specification. The manager of the company believes that there is a difference in proportions of parts produced within specifications by the. Investigate this belief. Random samples of the parts were produced on each of these shifts were collected. Day shift, 188 out of its 200 were met specifications. The night shift, 180 met specifications. Okay. So we're going to make a 96% confidence interval to estimate the difference in these proportions within the specification by the. Okay. Okay. Um, so we're going to call this a two proportion Z interval or difference of proportion. Um, let's say let P1 is equal to, let's say that's a day shift. Wouldn't I say it's proportion of day shift part? I'll just say meetings. I'll just say I'm just gonna say or specific specifications, whatever. And P2, I'll define it the same way with night. Okay. Gotta check our conditions for this. Um, so aren't we given random samples? And can't we assume day and night shifts are independent from each other? We have to assume. Let's put some values down. At one, that's my day shift. I have 180 out of 8 out of 200. That means my Q hat another 12. At 2, I think it's the FT 180 out of 200. Means my Q hat. Very small difference. We'll see. Okay, we have our N1 and N2. Both sample sizes are 200. We must assume must be less than 10% of all parts. I'll say all parts made in each case. Okay. I'm just gonna skip doing N1, P hat 1, and so on. Like, you should know how to do. Okay. So the formula, plus or minus. That's the formula. It's good to know it. However, you can go right to calculator. We're going to go to two proportions Z interval. All right, so then we have 188. What I have for that one? Yeah. Over 200 and 180 for 200. And we're doing this in 6 months. What? Press period, not enter. There. Okay. Get. Oh, okay. This is a very interesting answer. Put our answer down. Negative 0.0156. 0.0955. Okay. So there's something really important. This interval crosses 0. If it crosses 0, that means there's a possibility that these proportions are this sorry, yeah. These proportions are the same. Do I have I don't know. Oh, so based only on this confidence interval. Well, let's interpret it anyway. Think that the difference in proportion of parts produced with by the different 0. let's answer that one first. I'm just gonna no, okay. Let's say let me type. I say I am 6% confident that the difference in proportions of part meeting specification between night shift or day and night shift is as follows. So wouldn't this number here, that's if this is P1 minus P2 and I get a negative, doesn't that mean that uh, there's a chance that P1 is lower than P2? And that means night would be 1%. Day would be at worst 1.56% lower than night. Queen. Queen. So at one extreme, night could have 1.56% more part meeting spec. And at the other extreme, they might have 9.557% more part. I hope this makes sense because, like, this is saying if this is them being the same, then here's, I'll just say negative 0.01, meaning day has fewer than night, but at best we have 0.09, meaning day has 9% more. Okay, so last thing we have to do is to comment on do you think difference is different than 0? Say no, because 0 is a plausible value since it is in our confidence interval. In other words, it is plausible that you have the same portion of part. I hope this helped.